Welcome back. We are COMP2142, that's Game AI 1, in the winter 2026 semester at Georgian, and it's week 8, part 2 of our broadcast and recording together. And I got a question from Alex. Will the functions required for this assignment be included on the test? Yes. Yeah, I'm not going to remove stuff. I'm going to add things. I'm going to ask you for other things on the test. So that way it's not like I'm going to take things away. What are you talking about? Some of this, like the data structures, or other things? But all the functions, you'll have access to everything. I may just ask you to do different things with it. So we want to get into, we talked about new starter project. I want to get into data structures. I want to talk about stacks. And again, I know that some of you know this, and we briefly touched upon this already, but I want to talk about it again so that you guys are good. So stack, it's one of the most frequently used data structures that we've ever seen. That stacks and queues. Really what it is a list of items that are accessible only from the end of the list, which is called the top of the stack. Okay, so that's what it is. A stack is also known as last in, first out data structure, and the way that works is it's like a stack of plates or a stack of cards. So the last thing I put on the top of the stack is the first thing that we take off the top of the stack. That's how it works. That's how the input and output works on that kind of data structure. It's a very common data structure that we use, and the reason why is because it mirrors how something works in real life. We also use a stack for internal engine and programming structures. For example, the call stack. The call stack, the way it works is when we call a function, a copy of it is put up on the stack. And the stack that I'm talking about is memory stack, right? So it's kind of in memory, kind of like, from an execution flow perspective, every time I call a function, that first function's on the stack. And if I call a function from that function, another copy of that, another one goes to the stack, and keeps on doing that until that function, the last function I called, is resolved. Then it pops off the stack, and then it goes back to the previous function. It keeps doing that all the way back to the calling function. That's how the stack works for the most part. Memory stack, or the call stack, if you will. So stacks, there are two primary operations for stacks. There's either a push or a pop. Those are the two operations for a stack. So I push for the first time, push 1, and then what happens is you can see that that's the first element in the stack. If I push another one, the number 2, it goes to the top of the stack, right? If I push the number 3, it goes to the top of the stack. If I pop, notice I don't have a number that I pop, right? Popping means I remove that element off the stack. And so when I used the pop operation, it popped 3 off of the stack. So now there's only the number 2 and number 1, right? As an example. And if I pop again, I pop 2 off. So now I only have a stack that's 1 element high, right? And then if I push the number 4, it goes on the top. So Logan's asking, is it a sort of a more configurable array? Yeah, kind of. It is an array type, but well, it is a collection, right? One thing to note, a note about stacks and queues in Unreal Engine. Remember, there's only 3 structures in Unreal Engine: T-array, T-map, and a T-set. There is no stack, no queue, right? So we need to emulate how this works. Now, in the STL, so I wanted to talk about this as well. And if I go to C++, you can look this up as well, STL. And if I was to look at that, so here's the standard template library is what this is. I'm just going to choose a site here to show you. Let's use this one, Microsoft Learn, right? And so the STL, the standard template library, has a bunch of templates, and you can kind of search for things. If I look for stack here as an example, so this is the stack, and you can see that the standard template library has the stack class. There it is, and the stack class has a couple members, right? It has these operations: pop, push, the size, and you can also get the top. The standard template library is something that exists, and you have to include it: STL, : and so or standard STD : and then whatever you want to use. In this case, stack or queue. The other site that's really good for this, if I go back, if I go to W3 Schools, also very good. It talks about different things here. So here's the stack, right? And you can see here that it does. There are you know, kind of structures we can use that are built in. However, and this is the negative, Unreal Engine doesn't support any of them. Not 100%. So we need to create our own stacks and queues and all that stuff. Could we make use of something like this, the standard template library? The answer is yes, but we are recreating structures that are not supported in memory. You know, so the STL is kind of fat too. Some people don't like it. It is organized fairly well. Like, some people like the fact that it's got everything you need. So it has a stack, but we would have to create another one. So here is an example of a stack class that we would use using, from a data member perspective, just answering your question, Logan, a T array. So here, this stack is a stack of type integer. So it holds only integers. That's what it holds. We're going to call this private member stack array, right? And here are all the functions. So a public function would be a push function, right? Pop, peek is empty, size, and clear. And that's how it would look inside of, if you took this exact C++ code and created your own stack, you know, this is what it would look like. Notice that the U stack is what it would be, U stack, and it's based off a public U object. So U object is the superclass for all objects in Unreal Engine. Okay, so this is how it would work if I was going to make a stack class. Realistically, the back end would still be an array, right? Why? Because if we're using a T array, it's a managed array, and the memory for it, so we're not going to get a memory leak if we use a T array or anything like that. If you used a stack from the STL, you know, you could certainly do that as well, but you'd still have to, you know, you still have to connect it somehow to an actor or something like that in, or a U object. You can make your own stack class, but you'd have to make your own U object that you would inherit from inside of, you know, kind of C++. So that's definitely something you can do. So that is your stack class. Okay, so now exercise for you guys. I want you to recreate this stack class, right, in blueprints. That's what I want you to do, right? So let's take a moment. I want you all to do it as an exercise. So here is your C++. We've done this before a couple times now. This is like the third time I'm asking you to do this. I want you to recreate this stack class only in blueprints. Okay, so would you have a problem with it if I asked you to do it like this? Anyone has problems doing this kind of stuff? Please answer now, because I'm going to pause the video, then I'm going to come back and show you how to do it. But I'm going to give you some time to do it first. So here in class that we're in. Anybody? Yeah, I know it's not easy, but how about we do it together? And so that we can step through it. And please help me out. Okay? So I want to make a blueprint like this. Okay? I don't want to use C++. I'm against it. Let's say I don't like C++. Okay? And I want to make it work only with blueprints. How do I do it? Well, first of all, let's create a folder for this. And I'm just going to put it in my content folder. We'll call it structures. So, or data structures. Make a new folder called data structures. Here it is. Here's our data structures folder. And inside of my data structures folder, I'm going to make a new blueprint. So let's look at the blueprint class that I can make by itself. If I go blueprint class, I could choose actor. That's something I could definitely do, right? And inside here, I have other options as well. Take a look. Okay. One of them is object. So that is like what I'm doing here, UObject. So I could use object as my superclass, right? Now, warning, if I do that and if I don't choose actor, right, then we're going to make another blueprint later on or use it somehow in, we have to instantiate the object later on anyway, okay? Well, let's try it. Let's make an object, okay? So we're going to make it of type object. I'm going to click select, right? And now we're going to call it BP underscore, because it's still a blueprint, stack. There's my stack. Okay? Notice it's a different blueprint than what we would normally get. This asset that we're making is a very basic asset. It doesn't have anything inside of it. If I double click it, you'll see. It does not have a viewport, right? Because actor is what it has. I can't drag and drop this into the game world, kind of. Let me show you what I'm talking about here. So if I take this stack and I drag it onto the game world, notice how I have this like no can do sign, right? No entry. I can't do this, right? Because there's no visual aspect to this thing whatsoever, right? It's the lowest level. It's like me adding an object that's empty. Doesn't make sense for Unreal Engine's editor. So this is okay to do it this way, but you know, we have some things going on, right? But let's suppose we come like this. We have the event graph. We have that. And what we want to do here is we have a private T array called stack array. All right, so stack array is the name. It's of type integer. So let's add in a variable. We'll call it stack array. And it's of type T array. So it's of type array. So of integer. So integer array. That's the first thing. Let's make it visible. So actually it's private, so we'll make it invisible. And by the way, like I said, from an advanced perspective, you know, you can see that some other things that are here, some different values, compile and save, right? Instance editable, you can also mark it as private, so only usable within the class itself. So it can't be something that you can see. You won't be able to see this thing. For now, I'm not going to do that, but we could mark it as private if we want to. Okay, so something that we can do. Next, now that we have our data structure, I want to have several functions, and the first one would be the push function that takes in a value of type integer. All right, so again, I'm making a new function, right? We're going to call it push. It takes in something called value of type integer, right? So there it is, compile and save. And now that we have that, what does it do? We use the stack array add. So stack array and then dot add. There it is. And what are we going to do? The value is going to be added in here. So I could just do this as an example. That's perfectly fine. So push is more like a wrapper on a thing that adds something to the array. Now, one thing to note, array, when I add something, adds on to the end. Stack, when we get something, right, we get it from the beginning, the top of the stack. So we want to picture how we're going to use this structure, a T array, because a T array starts at the front and goes to the back, right? What we got to think about is when we're doing push and pop operations, we push to the back and we pop from the back too. Take from the back, not from the front. That's how we're going to use it, all right? Because it's going to simulate what a stack would look like anyway. So this is kind of what we do for the push. Compile and save. So that is our push function, right? Then I want to do the pop function. Now pop is a little bit more complex, right? So let's again add that in. Here's my pop function. The pop function is going to return an int32. So let's add a return type, and the return type is the value that we're going to get out of it. So here's output. We're going to call this value, right? And it's going to be of type integer. So it's going to return something. That's what the pop is going to return, right? All right, well, let's check if it's empty. So how do we check that? Well, if I take my stack array and I check to see is empty, notice that isEmpty is a function that's coming with all arrays, then I want to return 0. So that's okay. So first we branch. That's what this is. And that's the first thing we're checking, right? And by the way, it's easier for us to see this as a sequence because that's how this is written in a sequence, right? So this is the first sequence node, this is the second sequence node, this is the third, and so on, okay? And if you look at code like this, like each one being a sequence line, then it's easier for us to think about, okay, how we're looking at. So this is the first sequence, we're going to branch. Okay, and then if true, if it's actually empty, we're going to return 0, which is this. Now we could return a funny number. We could return -1, which is basically, you know, doesn't make any sense, you know, or whatever. 0 could be a value, you know, as an example. In an integer, it's an integer value, but we're going to return 0. So that's what we're going to do. So if it's empty, we're always going to return 0. That's what we're going to. That's what our pop is going to do. Okay. Next is the removed value, right? That's what we're going to say. So we're going to make a local variable called remove value of type integer. That's the remove value. It's an integer single. There we go. And then we're going to say that that's equal to the last member of the stack array. So let's try that. So stack array, and then remove. By the way, if I type this last, so last index, right? And I want to, that gives me the index, the last thing I want to remove because I'm popping stuff off the end. I'm not getting it from the beginning, right? So that's something I want to do. I want to remove the last index, whatever that is, right? And that last index, I want to, that's what this is. That's this value, right? So remove value is going to be this one. This is the, not the remove value. This is the removed index, the last index, right? So remove value is I want to get the object from that last position. So then I would get this stack array get, right? And I want to get that value. So that value is going to be like this. Now I could have make this line go here. I'm just making it so it's simple to see. So I get, this gives me the index, the last value from the array. That's what I'm doing. Okay. Now this is the remove value, and I'm going to assign it to here because that's what it's going to be. This is the remove value, and this is the second line that I'm using. By the way, stop me if you don't understand what I did or what my thinking is. Okay, please. There we go. Okay, next, stack array remove at stack array num -1. So that's the length -1, right? But I also could use last. It's kind of the same thing. I could have used stack array last, kind of the same thing, but we could do that. So that's the next thing I want to do. So I'm going to say stack array remove, and so remove item means I have to search for an item. This is the item to remove from the array, right? That's what remove does. That searches for a specific item. Remove index, which means if I hover over it says remove item at the given index from the array, right? So that's this again, this last index again. I want to take the last index and I want to use that. So if I take this part, now I want to be the same, so I did it differently here. I could have done stack array length. This is another way to get the last index. Instead of getting the last index, I can get the length -1, right? Because the length is, let's say, for example, 10 characters, then the length -1 is 9. That'd be the last index, right? So it's kind of the same thing. By the way, I could have done the same thing here. Instead of stack array last index, I could have said stack array length -1. So these are the same. I'm just showing you there's two different ways of doing it. Here. So remove that index. I remove the last thing. So first, I saved it. This part right here, this step 2, it saves the object that I've just removed, the number, right? And I've saved it inside of remove value, this thing, okay? And then finally, I return it. So again, I'm being very wordy here where I'm doing this, but here I'm just going to return the value, which is the remove value. And that, my friends, is the pop function. Okay, so again, line by line, I highly recommend when you see something like this, you go sequence by sequence. Each one of these is a sequence line. Okay, next, peek. So let's do that. So sometimes I want to be able to peek at a value without removing it, right? That's what that is. And peek is going to peek at, so peek at the top element. So that's the last element for us, right? So again, if empty returns 0, that's the same as what we had in pop, this part. Okay. And let's make it a sequence node. So that's the first thing. So if it's empty, we're going to return 0. One thing we might also do is throw an error that basically says it's empty. We're trying to get something that's empty. One thing with push is an operation, so we should make sure that the function has an execution node. Pop, definitely an execution node is required because we're getting a return value. But peek, maybe this could be a pure function where we're actually just looking at something. We're not actually doing anything with it. We're just getting a value. And we're not actually doing anything to the stack. We're just looking at or getting a value, and so that's why it might be a good pure function to use here. The other thing is return stack array last. So again, if I was to look at this stack array, and then if I was going to look at last index is just the index, and then I would do get. Right? So that's the one I'm getting. I'm not removing it, I'm just getting it, and I'm returning it. So the last value in the array is the one that I'm going to use. Okay, so that is peek. Okay, compile and save. Is empty, that's kind of a wrapper for what we already have. Right, so is empty in here is it's going to return a Boolean, right? So maybe we'll call it empty like that, and we'll make it so that it's a Boolean, and we'll also make it a pure function because we're not doing anything to it, right? And the way we can check that is if we use our stack array is empty, and we're returning that. So this is just a wrapper for this, right? Instead of me saying stack array is empty, I can just say is empty, right? And this is where I can make stack array private, and we'll still have access to knowing if it's empty or not. Okay. File and save. So is empty, peek, pop, push. Those are done. Size is just the array length. So again, I can do that. Oops. Delete. So size, and I can get the stack array length. We just renamed it. All we're doing is we're kind of returning the size. Size is going to be an int32, so we're going to kind of return the size here. And again, I highly recommend, maybe we'll call it value. I highly recommend we make this a pure function because there's no need for us to, to get the size by passing in an execution pin, right? There's nothing that's happening to it. And then finally, clear, that I would say requires an execution because we're actually changing the array itself. Anything we change, I highly recommend we use an execution pin for this. So again, stack array is actually got a clear function to it, and I would just do one of these. So it's just basically it's just the clear function allows me to kind of pass through. So clear instead of stack array clear, we can just do clear like this. Compile and save. All right, so that is the entire object, right? And now we have our stack. Are you with me? Was that kind of step-by-step process something that you could follow? Why am I showing you this? You're going to get my friends, you're going to get some code from the internet. And it's not going to be related to Unreal Engine. It's something that you want to use. You've seen a piece of code, an algorithm, and you want to try and do something in Unreal Engine or whatever. How are you going to do that? You need to be able to understand how to convert it from C++ into blueprints and vice versa. All right, so now how do I use it? So now that I have my stack, there's my stack. I want to use this thing somewhere. So we know we have some blueprints that we can use, a grid character, right? So in my event graph, I'm just going to go to my event begin play. Here it is. And let's just make some room. I'm just going to kind of take all that and put it down here. In the meantime, let's put this up on DevOps. So we'll say file, save all. And we'll say git add dot, git commit -m. We'll say added stack class, kind of. So you see what it looks like. Okay, and in here, for now, I'm just going to push this aside because we don't need it. I'm going to make another execution pin here. And what I want to do is I want to, if I do create, notice that there is create object, create widget, create drag and drop, right? And there's a bunch of other stuff here. But what I want to do is I want to kind of do the same thing. I want to create an object. So if I say create object, right? Create save game object, that's what I can do. But is there a way to instantiate? And there is, this one right here. See where it says construct object from class? So if I click this, construct object from class, we can choose BP underscore stack. Here it is. So what this is going to do is it's going to construct a stack. That's what it's going to do. And so this is the actual stack itself. I want to save it. This is the return value. I want to save it as something. Let's call, make a new value here. So I'm going to kind of right click and promote to variable. We'll call this stack, right? Which is of type BP stack object reference. That's what it is. Okay. And I'm going to make it so that it's visible so we can see it. Here's my stack. And now after I've made my stack, let's use another execution pin for this. So first we create our stack. So create stack. Okay. And after we create it, I want to use it. So what I can do is I can say something, hey stack, let's push a value onto it. What value do I want to push onto the stack? Let's push the value 5. Okay. And let's do it again. Let's push the value 10. And let's push the value 15. So 5, 10, 15, like that. Okay, so we're going to push 3 values onto the stack. 1, 2, 3. All right. So let's compile and save and test and see what happens if we do that. Does it crash the code? And the answer is it doesn't, right? But here's something. If I go back to inspect it, if I go to grid character, and if I look at stack, right? Stack is a thing, but we don't see anything inside of it. We can't see the stack, right? Because we can't inspect the stack. The only way we can inspect the stack is if we have access to that stack array, which is private right now, okay? So we can't really do anything like actually look inside the stack here in the inspector. The only way we'd be able to do something like that is if we went to our stack and we made the stack array visible, right? And if we did that, and if we ran it, you know, as an example, and if I look at character, then if I look at stack, right, then the stack itself is something we have access to, yay, but I can't see anything inside the stack. Again, the stack is not something that I can see, right, because we're not looking at that thing here. It's accessible. I can look at it, right, like the actual object has been created, right, but I can't really do anything with it. So it'd be nice if we print out the value of the stack after every operation. How about that? Okay, so we can't do anything like that. So even if we were to, you know, kind of show the value here, yeah, it's good. That means that in the grid character, I could do something like, hey, stack, you know, kind of get stack array, and I can do it this way. I can get the stack array, and from here, do something, right? I could show the stack array. Maybe I can even make it so that the stack array itself could be promoted to a variable, and then you can see it. So if I promoted this to a variable, let's just call it stack array, you know, as an example, here, if I wanted to show it this way really quickly, so I could do it that way as well. And then here's the grid character, you know, and if I look at stack, here's my stack, and did I make it accessible? Of course I did. Let's try that again. Sorry. There it is, 5, 10, 15. You can see it added it in that order, 0, 1, 2, whatever, right? So my question to you is, right, 15 was the last thing we added. So that's the last value. When I pop, if I pop it off the stack, then it's going to pop 15 off, and I'm going to have 5 and 10, right, as an example. So again, the way this would work is, if I was to pop, let's just add another one of these, right? So stack, just to test it, and if I did pop, right, then now we're only going to have, so 5, 10, 15, the reason why it doesn't show 5 and 10 only is because the stack array itself was only set based on the stack array that we had before. So I'd have to reset it again. In other words, I'd have to do kind of the same thing. I'd have to do this again here, right? Like afterwards. Because the stack array is just a value. It's not, even though it's a reference, it's not going to work unless, you know, I update that stack array over and over again. Sorry, I meant to do it here. Right? So it'd be nice if, instead of doing all that, we had another little function on the stack called toString, right? So let's make that toString function. Now it's not included, but what I want to do is I want to print the stack in order, right? Instead of like 5, 10, 15, I want to make it so that the last member, it's last in, first out. So it should be like 15, 10, 5. That should be the stack of cards. Top of the stack is the last thing I entered, right? So how do I count backwards? Well, if I go for each loop, right? That's one way, but there's also for each loop. And notice that there is a reverse for each loop that I can use. We've kind of done this before, right? So I want to get the array, that's the stack array Here it is, right? And I want to, I don't care about the array index in this case. All I care about is printing print string. And I want to print string the array element here. I want to print the array element. You know, kind of, that's what I want to do, right? But this is going to print each one down like this. So, so if I was to do this toString method like this, let me show you. Again, this should probably be a pure function because we don't have anything. We're not doing anything. We're just peeking at the values, right? That's all we're doing here. So I want to be able to do something like this, you know, as an example, print string after, you know, our operations, right? So I don't need to do this necessarily, or this. I don't care about the stack array anymore because we don't care about seeing that stuff, and it's also messy. So I push something, print string, or maybe I can do it here. I can print string, so I can say stack print string or toString. All right. So toString is going to print out this thing. Now, I made it a pure function. Maybe I spoke too soon. We should probably make it so that we can just include it just like this, because we're actually printing out the stuff right there. So let's make it so it has an execution pin. There we go. And that's when I kind of gather everything, and I'll do another one of these here. So I want to print it twice. So this is the first one. The first operation is adding 3 values. Then we pop a value off, and then we have the new string, whatever's there. Let's try this out and see how it works when I run it. So we should have 510, 510. Sorry, let's try this again. And so 510 and then 510, 15. So let me explain what happened here. So it goes, this is the log, right? So it goes 10, 15, 10, 5. That's the first operation we did. In reverse order, that's the top of the stack, 15, because the last thing we added in, right? Then we popped 15 off, and now we only have 10 and 5. So those are the 2 operations. So you can see it works just like a stack would. That's our proof right there. I can make it nicer, where instead of printing it this way, right? You know, as an example, I could have a string that I print out, you know, kind of like something else. Let's call it a local variable. We'll call that print string, something to print, right? And make it a string. And then what I'll do is, instead of printing the string right away, I want to take the value, so print string, I want to set it to whatever the value is, right? And then I want to append something else. So I want to append string. Sorry. Append string. There it is. So I have 2 strings that I want to add together. So I want to take my value from the array. So here's my array element, right? I want to convert it to a string, and then I want to add a space. So this, that, and then add it to the string. So that's kind of simple way of doing it. And then that's my print string. And that's my first thing. So I loop through all that, and then when I'm done, so instead of using a sequence node, when I've completed the array, then I want to print it out. So I could print out the print string. So I could say print node. Right? And then I can just take this print string and output it. Okay, so that's kind of uncompleted. So I could do something like this. And so now my print string will be this way as opposed to this way. Let's also make the string last a little longer. It's not really lasting. Let's make it 30 seconds. All right, let's compile and save. And print. And oh man, it just printed 5 twice. Why? What happened? How come it only did 5 and that's all? So array element, added this in, and we set the print string. Well, we set the print string, we appended it, right? But that always sets it to the first element. So I want to, kind of append to this, continuously append to the string. So basically it's almost like I take the original string, which is nothing, right? And then I append the new value onto it, right? So how do I do that, right? Because that's what I'm really doing. I'm taking the original string and adding it onto, it's almost like I'm taking this print string and let's add another pin, right? Add pin. And I'm kind of doing one of these. So I'm saying, hey, whatever that original value is comes first, and then I add in the second one. So it's actually the other way around, like so. So I take whatever the value of the string was, I add a space to it, and then I add it in. This is not accurate. We're still not quite there, because what about in the first iteration? We haven't got anything. If the string is empty, we don't do this, right? We do something else. But let's suppose this is okay for us. Okay, so if we did this and press play, now we're going to have 10, 15, 5, 10, 15. So the first thing is 15, 10, 5, and then 10, 5. So that's kind of the same thing we did, but you can see this is the first one, this is the second one. Okay, so it kind of does the same thing. So we can play around with this as much as you want, but this is kind of the first thing. Questions around what we're doing here with stack. We're emulating a stack with T-array. The next part we want to talk about as we move on. We're moving on now, moving on. Okay, so I'm going to go back to this, and this is just our testing. So we're going to get rid of all this stuff, right? That was just testing our stack, so we understand how that works. We'll keep the stack there because we can see that that's how we construct a stack. And now we're going to make something else. So what about then a queue? What's the difference between a stack and a queue? Well, a queue is still a data structure where the data enters at the end of the list, or the rear of the list, if you will, right? And it's removed from the front of the list, right? So this is a type that's called first in, first out. It's like a lineup at the bank machine, right? Or you're waiting for tickets to a show, going to the movies, I guess, right? Or you're lined up to get gas with your car, and it's first come, first serve. You're going to buy food at the restaurant or whatever, or at a cafeteria, you're waiting in line to get served, or you're waiting in line to pay, at a grocery store, right? That's kind of what first in, first out is, right? So first come, first serve. A queue, to me, in game dev, is one of the most common things we use. We use a queue for a bullet manager, a bullet pool, where I kind of pre-fill a container full of bullets, right, as an example. And then what I do is I kind of take the first bullet that's available from the front of the queue, and I use that, as an example. I dequeue it, I remove it, and when I dequeue that thing, I have that bullet. And so what I do is when I'm done with the bullet, I put it at the back of the queue again, right? So what I'm doing is I'm putting it back at the lineup. I'm reusing. It's almost like a cyclical reuse of an object. Instead of putting it at the front loading it like a stack, right? I don't do it that way. I use a queue for a bullet pool. I also use a queue, a priority queue, which we're going to use for pathfinding, right? So let's think about how this works. So queue operations, there are two. There's one called on queue, and the other one is called dequeue, right? When we on queue something, we add an object at the end of the line, right? And when we dequeue something, right, then we take an object from the front of the line. Okay, so back and front. So when we, let's suppose the lineup starts here, and we're being served on the left side of the house over here, right? And so here there's I don't know, you're getting coffee or whatever at Tim Hortons or your favorite coffee shop. And so you arrive, that's A, right? And then B arrives in the queue. They go here and they're waiting in line. And then C arrives at the queue at the end, right? And then A departs. Notice that B and C get shifted, to the front of the line. That's what happens, right? And then C, when B departs, C is left for their turn. Now, how do we simulate this with a T array? It's more difficult, right? And it's more difficult because for a queue to work properly, right, we have to kind of simulate back and front operations. One thing to note is that it kind of looks a little different. So let's do this one now, right, to simulate what it looks like. So again, I'm going to do the same thing for us using the same PowerPoint. I'm going to go back and make a new blueprint class of type object, right? And we'll call it BP underscore Q. Again, I'm storing this up on DevOps, so you can always look at this to kind of get your mind around how this would work from a blueprint perspective, right? But my friends, realistically, I wouldn't do a blueprint like this. I would do it on the on C++ side, right? We can actually implement this on the C++ side instead, right? And it would be just us taking this code, putting it in C++. How would we use it? The exact same way we just use the stack, right? Which would be, we have to construct an object, and then we would use it. Let's do it. Let's go through the exercise anyway. So here's onQ, right? Notice that what we're doing is we're doing QArrayAdd, right, for onQ. DQ, as an example. Now this is where it becomes a little bit more challenging. We're removing at the front. So one beautiful thing about T arrays is it allows us to remove from anywhere we want. Remove a value from any index, and then the array will adjust. A standard array, if we're going to use a standard array, let's say in C++, standard arrays are immutable. They can't be changed. What we're doing with the T array is on the background somewhere, someone has programmed it so that when we remove something from an array, right, then what happens is it remakes a new array and reallocates the memory. Because a true array doesn't have any of this monkey business. You can't remove it from the beginning or the end or the middle. You can't do that, right? That's like a list in other languages. So if you look at a C# list, right, or a list in in C++, that's kind of what our array is, right? It's kind of like a list, to some degree, right? So that's what that kind of thing is. It's like, we have a much more flexible object that we're using the entire time. So that's why it allows us to do these operations where I can remove from the front, right? I add to the back, that's what add does, and I remove from the front. Okay, so it's almost the exact same as the stuff that we have. These functions are all the same, right? And this function is the same, but it's just named differently. So let's do that. So really quickly, we'll make those functions. One thing we can do is to cheat a bit, right? So we can go to the stack class, and I can just take, one thing we might be able to do, let's go do this quickly, is I'll get rid of this 1 second, delete, and let's duplicate the stack for a second. Let's duplicate, right? And we'll call this BP underscore Q, right? Here's a quick way of doing it. I'm cheating, and let's just rename this from stack array to Q array. There we go. And instead of push, that's going to be onQ. So we'll rename that function onQ, right? And pop is going to be DQ. We have to fix it. DQ. It's not working properly right now because it's still doing the same thing. DQ peak is the exact same, right? But well, kind of. Peak only peaks at the beginning, right, all the time. So that's going to be different. So I'm going to modify that. Is empty is the exact same. Size the exact same. Clear is the exact same. And toString needs to be adjusted. But at least most of our structures are ready to go, right? So let's go back into our DQ. So DQ is not like this. DQ checks to see if it's empty, right? And then the removed value is the first value. So let's just do one of these, right? So remove value, that's the remove value, right? So we'll set the remove value, and the remove value is the Q array, get 0. That's what the remove value is always, right? Because it's always the front of the array that we're removing. So that's the value that we're removing. That's the remove value, right? First we have to save it. This basically saves a reference or saves that value before we we remove it. Okay, then we remove the value, so Q, and remove. And now we remove an index. Remove that at index, right? So the index we want to remove is 0 all the time, because the first value that we're removing. So that's the thing we're going to do. Remove it. That's what this is. Remove at 0. And then we return the remove value. Right? So we're going to return remove value here. So that is the difference between a queue and a stack. It's actually a little bit more straightforward, because we don't have to care. We don't care about last. All we care about is first, which is 0 every single time. Compile and save. So that's DQ. Peek is the same. Peek doesn't work the way this does. We check to see if it's empty. That's correct. But then we'll keep the return value. But then what we want to do is when we peek, right, we want to return the last value or the first value. So Q array get, right, we're just returning that. That's all we're doing. That's what peek does, because we're only peeking at the front of the array, right? Compile and save. So peek is done, DQ is done, onQ is the same, right? Size, clear, toString is not the same. So toString now is going to go front to back, just like a loop, basically. So we can, instead of using a reverse loop, we can still keep this part where we want to aggregate our loop, but let's just change this to a for each loop. A regular for each loop is what we're going to do, where we pass in the array. Here's the loop body, and then when it's completed, we're going to do this, and then the array element is the thing that we're casting on. So that's going to be the loop body this time. There we go. So now we have all the elements that we had for in the queue, for the stack we have in the queue. So let's put that up on DevOps. So file, save all, and here we're going to say git commit -m. We'll say added queue class. Okay, nice and easy. And we don't need all of these, but we want to definitely construct. So if we do construct object from class, we're going to choose bp_q. Here's the q class. Okay, and we're going to call this promote to variable. We're going to call this a q, right? So we'll say create q. There we go. And let's do some queue operations. So that's the next line. So what we're going to do is we're going to say, hey queue, I want to on queue a value, and we'll on queue again. We'll do that 5, 10, 15 this time. So we'll say 5. That'll be at the beginning of the queue, and we'll do the same thing with the other ones, 5, 10, 15. So this is adding it to the back of the line, basically, in order. So 5, 10, 15, right? And then what we want to do is we want to queue toString, which prints out the queue. And then what we want to do, I know it's messy, but then what we want to do is we want to queue DQ. Okay, notice that it gives me the value. That's the difference. Pop also gives me the value, right? But DQ actually removes it and then returns whatever that value is that I returned. So that's the value that I want out. And that's why it's really nice to work with queues when it comes to pathfinding. So example would be, I add something to the queue, right? And so our queue, the one we're going to make in the future, our priority queue is going to be two things. One, it's going to have a queue of tiles, right? Each queue of tiles, right, is going to have a tile that we're adding on and we're removing. That's what we're going to do, a tile. And we're going to add neighbor tiles, the neighbor tiles around in order, right? So top, right, you know, and so those 8 tiles, we're going to add them all. We're going to queue them all up, right, in order. But then what happens is we're going to use a priority queue. And the priority queue is going to be a special queue where it peeks inside of each tile and says, what value do you have? What's your length, if you will? What traversal value? What's your G cost, right? And if that G cost is lower, it's going to be at the top. It's going to be in the front of the line, right? And if the G cost is higher, it's going to go towards the bubble to the back of the line, right? And the reason why we want to sort the queue this way, because that's what a priority queue is. It's a sorted queue in ascending order, right? From lowest to highest, is we want the lowest cost, right? And so this way, we'll pick one of the 8 neighbor tiles inside of our queue. That's the lowest cost. That's the first neighbor tile that's the lowest cost is what we're going to pick, okay? So we're going to dequeue this, that value, the value at the front of the line, right? And then we want to print out the queue that remains. So what we can expect is 5, 10, 15 is what it's going to say in the list instead of 15, 10, 5, like how we had it before. 5, 10, 15. That's what the print string is going to say. When we dequeue, we're going to take the 5 away, and then when we print it again, it's going to say 10, 15. Let's try that. So 10, 15 is going to appear first because that's the last thing that was printed. Okay. Compile and save, and try it. So there it is. So again, if I look at the output log, 5, 10, 15 is the lineup, and then 5 is finished doing its business. So it leaves, and now 10, 15 is what's left. So it works now. The queue works exactly how it should. So that is your queue. Questions around any of this? Do you understand how I did it? And a quick way I did it by copying the stack because it almost has very similar operations, just the way it manipulates data is different. Anybody? You guys good? So again, one thing to note, which is really important, is this construct node. The construct node is the thing that actually creates the data object. That's where we're holding all of our data. We need to construct it, as opposed to how we're doing it anywhere else. Instead of instantiating it, you can't instantiate an object without doing this, right? Remember that there is no blueprint, right? I'm not putting it into the game world. I'm constructing a data object here, our own custom collection, if you will, right? The 2 collections we made is a stack and a queue. These are custom collections that we've created that are holding data. In our case, only integers, right? We can make them hold anything we want, tiles, whatever. So that's something we can do. Okay, so that is this, and that was our test. So these 2 structures both work. I'm just going to delete those because that was just for, what we did. I'm just going to remove some of these pins because that was just for testing. Next, linked lists. We're almost done, guys. I know it's long today, but I have to talk about these data structures so you understand how they work, and so that way we can recall this video when I ask you to make a priority queue, right? So linked lists, what are they like? So data that's best stored in linked lists, day-to-day life, like a to-do list. They're all linked together, right? A grocery list, top 10 lists, right? And usually tasks that have to be done in a specific order. I have to do task 1, task 2, task 3, task 4, task 5, and so on. A sequence node is, in a way, a type of linked list where I do the first one, then I have to go to the next one, and then I got to go to the next one, and they're all linked together. Linked lists are another way we can represent our game world, if you think about it, right? Instead of representing our game world with a bunch of tiles, I can make nodes, right? And each node has the next node that it's going to. Each node in a linked list only points to one other node, right? So that's the disadvantage. Linked lists only point, there's actually a couple of different kinds of linked lists that we're going to talk about, right now. So let's talk about the problem with arrays. So the problem with arrays in most languages is that although arrays provide super fast access because each array, we talked about this a couple of weeks ago, each array is, they store memory in contiguous locations. So that means like next to each other in memory. In your random access memory, RAM, it kind of stores everything in contiguous locations next to each other. So reading through memory is super fast, like crazy fast, because they're right next to each other, memory location wise, right? But the problem with it is, they're immutable. You can't change an array. You can't move things around. A standard array we're talking about in most languages, right? We also saw that searching through an unordered array is really slow, which means we have to sort it in order for us to do things, right? Shifting elements around is also a computationally expensive, thing. Whereas with a linked list of elements, right, we can manipulate the elements a little bit better. So why am I telling you this? Because realistically, a RT array in Unreal Engine is a special managed array, which is a linked list. Okay, that's really what it is, right? Even though it says it's an array, it's not really an array. It's a T array. It's a managed array. A managed array where we're managing memory, right? Because we're managing memory, we have all these really cool operations like add and remove. We don't have that with an array. Array has like an index, and that's all we have, right? When we access an array in real programming, right? So even though we're calling it array, it's not really an array. It's a list. That's what it is. Or the closest thing to it would be a list. That's one thing to know. So let's think about linked lists. So each node has something called a successor node. All right, that's the language. We have, basically what we have is the payload. Each node has a payload, some data, right, that it's carrying around with it, okay? And then it has a pointer to the next node. Okay, that's what a linked list is. And you can see that each node, this is a node, this is another node, this is a third node, node 0, 1, 2. They're all pointing to each other. One thing about a list is we don't care about index. We don't care about that. It's just a collection of nodes, really, that point to each other, right? When we traverse a list, we start at the 0th node, the head of the list, which is what we're pointing to, and we keep going until the next node has no more nodes after it. That's the end of the list. That's how a linked list works, all right? So we use a node reference. The next node is a node reference to the next, that's what the next is, just a node reference, a pointer to the next node, okay? So that's what it works like. So moving or traversing through a linked list involves following the links from the beginning node, the head, all the way until the last node is null. We have nothing else left, as an example. Okay, so here's the head. I want to do an insertion operation. This is what actually happens in a T array, right? When I do an insertion, then what I'm kind of looking where in the list it has. So one thing that the T array has that makes it feel like an array is an index. It actually keeps track of its own position, right? So 0, 1, 2, whatever. Instead of it just having the head it also has an idea of where it is, right? But when I want to insert a node somewhere, again, if I go back to let's make another thing. Let's call it my array. And if I went and I kind of made it an array of integers, let's just do that just to show you. Here's an array of integers. So here's my array. And my array, you can see the operations that I can do. I can add to it. I can add a unique item. I can add a set of items, right? So add items is a set of items that I can add in all at once, right? That's what I can do. All right, so these are all the operations. I can remove, if I type in remove, I can remove an item, I can remove items, I can remove index. If I do an insert, I can also insert an item in a specific index and whatever the item is, the data that I want to insert. Now, because I've made it of integer, let's just change this just to make it more apparent. I'll make it a float array, right? So you can see what this looks like. One second. Probably easier just to rename. So here's my array. and my float array. And the first thing is the item to insert. Let's just do this again. So here's my array, and I want to insert an item. And notice that the insertion is green, right? That's the item that I'm inserting, the data that I'm inserting. And this is the index of where I'm inserting it, okay? So this insertion function actually looks like this, where each node has an index, and we say, I want to insert at index whatever, 1, and it pushes 1 down the list, and it inserts the new data in the middle. And now what it does is this new node points to the previous node that was there. That's what happens. So this is the insertion, the way it does the insertion. It actually adds it in here, okay? So that's what this insert function does. So again, for us to have an insert function for an array, it's not really an array, it's a list. Okay, so that's one thing. The other thing that we can do is when we remove a node, again, it's the same thing. We add a node this way, and when we remove a node, we can remove at. So again, one thing is if I go remove, there's remove index. So I remove item at a given index. I remove that, and what happens is it reforms the linked list so that the list updates its index and updates all the other elements in the array, so they have the proper index as well, right? And remove items, I can select items to be removed. I can also search for a specific item in the array, right, to remove. So this is not by index, but by a number. And if I hover over, it says remove all instances of the item from the array. This is different than the first index. That means that if I have a number, let's say for example I have the number 5 that appears in our array like 5 times, all the 5s will be gone. If I put in 5 in here, 5.0, all the 5.0s are gone, right? All items. So again, sometimes this is really valuable to be able to do. That's what the array does, right? Doubly linked lists, this is interesting. What they do is not only do they know the next member, but they also know about the previous member, right? So you can traverse a list. This is what a node would look like. A node would have the payload, which is the data, a pointer that points to the previous node, and a pointer that points to the next node. So a doubly linked list, right, is what this is, where I can traverse in both directions. I can go up and down the list. I can go reverse if I want to, or if I can go forward. So let's think about this. If I can do it reverse, if I can go back, right, that means maybe my T array in many ways is like a doubly linked list. It's got that capability because I can really traverse back and forth with a for each loop, right? So if I can reverse my for each loop, now there's different ways this can work, this for each loop. If we expand this, remember we can expand the node, right? Maybe that's not a good idea. Undo. If we expand the node, let's put that over here. So see what that looks like, right? And we've done this expansion before. Here's my array. This is what happens, as an example. This is what's going on, and let me just undo that change. And let me connect it, and let's try that again. Let's see if it makes a difference. It does. It absolutely does. Yeah. So it connected it here and here, right? So this insanity is what it's actually doing with a list, right? And it's looping it's actually doing a for loop in reverse. That's what it's doing, where the counter is counting backwards. So it's subtracting the length minus 1, as an example, and it keeps on looping through from one thing to the other. So I still think it's doing this this methodology. It's kind of using just a regular it's kind of got indices that are built in, and what's happening with this is the for loop is doing all the heavy lifting. It's not inside the my array or the T array itself, but in the back end, that's what's going on. So why am I showing you all this? Because you got to figure out how powerful an array is in Unreal Engine. It's got a lot of stuff inside of it. It's not a simple data structure like an array in C++. It's beyond that, right? And your mind should be, in your mind, you should think about this. When you're making an array, you're actually adding quite a bit of memory, right? Because you're adding something that is a managed collection, a managed data structure that you're using all the time, right? I believe it's not a doubly linked list. It's probably just a regular linked list that you're using in the back end. There's also called a circular linked list. Okay, circular linked list is a singly linked list that also, there is no null. The null points to the first at the end. The end points to the front. This is a great way of creating something like we did already in AI for your exam, which was, if you think about this, patrol points is what we've done. We've created a set of patrol points that point to the next patrol point. That's kind of an example of a linked list, right? Where each patrol point points to the next one, right? And so you have an enemy that goes to the first patrol point, and then it gets the information about where to go next, and it goes to that patrol point next, and so on. Again, but a linked list can also be a set of instructions. I want it to follow a set of instructions. I can create a node, and that would be the instruction node. Do this, whatever that thing is, right? A set of actions that it's going to take. And then do this, almost like a sequence of events, things that you're going to follow. As an example, a sequence of decisions that have to be made, you know. A circular doubly linked list is where it's circular. You can go from in either direction. You can traverse in either direction, and it's going to loop the other way, right? As an example. And this is, again, a great example of doing that. If you have a, depending on which direction you're going in, if I'm going in a clockwise, or I'm going to use the British term, anti-clockwise direction, counterclockwise, right? It doesn't matter. You can continue looping in one way or the other when it comes to your data structure, which is kind of cool. So those structures do exist. And all of these things that I'm showing you, my friends, this is the last thing we're going to talk about today. All of these things are there to solve problems in coding. That's what they're there. Okay? So I want to leave you with this thought. Okay? And I want to see, if you're able to think about this. If I look at a priority queue, right, in C++, let's take a look at what that looks like. Here's a priority queue in C++, right? And by the way, here is the CPP reference. It's a great place to look for priority queue, right? And this is typically what you would see with your, library. So this is the standard library, standard priority queue, right, as an example. And you can see here that we have several different kinds of operations, right? I can push back or pop back, right? So that's one thing I can do, which also is like a dequeue, right? And you can see that these are the different kinds of operations you can do. You can do a push. I can do an in place, right? I can do a pop, or I can do a swap, which is kind of cool, right? So the swap is a really great thing for it to include, because swapping allows me to swap two elements without doing that swapping code that we had over the last two data structures lessons, right? So I can swap two elements without doing it myself. It's already built in, which is pretty cool. That's actually a nice little operation to do for us as well, right? So that's what it looks like. And it gives you an example of how to use this code in pure C++, right? So here it is, right? And you can see here that we have our main, and there's a priority queue. We make it a standard priority queue of type integer. We'll call this maximum priority. We have our data, right? Our data, which is 1, 8, 5, 6, 3, 4, and so on. And then we do a for loop. And then what we say is maximum priority queue, and we push a value n, right, from our data. For every value in data, for every element in the data, we push all of this onto the queue. Now we're using push here instead of on queue and dequeue, but this is the way it's done. Okay, so here's what it would look like in order for you to use this stuff. And then what this does is it sorts it in priority order. So it makes it so it's like sorted in order. And so notice it looks like, this is our data. And then what happens is my maximum priority queue, the max priority queue, sorts it in highest to lowest, right? The min priority queue sorts it from lowest to highest, okay? And what they do here for the min priority queue, because we set up a maximum priority queue right here of type int, right? And if I go to the minimum priority queue, so standard priority queue, and notice it says makes the max priority queue act as a min priority queue, right? We have an integer and a standard vector. So remember, vector in C++ is not a vector like you remember. It's not a one-dimensional vector or whatever. A vector is actually a list, right? So that's how it works. So if you click on this thing, then you can see that a standard vector is a collection, a container. That's a container, and except for standard vector bool, right? As an example, a vector is a sequence container that encapsulates dynamic size array. So it's a dynamic array, which means it's a managed array, and a vector has a couple of operations. One of them is pushback, right? And another one is popback. So you can only push back and pop back. Actually, a vector in standard C++ almost works like a stack in many ways. Pushback and popback, right? So that's one thing that it looks like as well. So really cool stuff that actually exists that's already there. Now the other thing to look at, one more thing to look at before I let you guys go, is if I look at a priority queue in C#. Okay, I want to kind of show you the difference between a priority queue and in C++ and in C#. It shouldn't matter, the language, by the way. But one thing to notice is that here it uses all the nice words, right? So here's dequeue, removes and returns the minimal element from the priority queue. That's what dequeue does, because now we're making it so it's the minimum, not the maximum. It's not a max queue, it's a min queue, right? And then you know, we have a peek function, we have a toString function, and we have other things in here as well. We can also have other things where we want to compare two queues, where we want to say, is this one equal to that one? So we have a dequeue and an onqueue, and notice it says the element is what we want, and a priority, T priority, adds a specified element with associated priority to the queue. So what's the priority? And it depends on whatever you want, right? So if the priority is lower or higher, you have to create the priority here in C#, right? Similar to that, we have to do the same thing in C++. When we make our own priority queue, we get to determine how we order it. We have to sort the array in many ways. So if I was going to do it in Unreal Engine, then if we think about it, if I take my array, remember my array has some other objects, I can also sort the array, right? So that's something that's interesting. So the array can be sorted, and you can choose the array's sorting order. I can choose ascending or descending, right? If I choose ascending, it means lowest to highest, right? Which is kind of what we want with our priority queue. We want to sort from lowest to highest, right? So it has a sort function. That's one thing that's very important to understand, right? And what about a search function? If I do a search function, it doesn't exist, but I could do, what about a find? There's find item. We've done this before. I want to find an item that looks like this. Where is it? So we have both sorting and searching inside of our array. It's very powerful, my friends, right? So I wanted to share all this with you because as we move into you know, creating our data structures, I'm just going to clean up the stuff that we've done so far because we don't need any of this stuff. Remove execution pin. I'm also going to get rid of these references because we don't need that right now. As we create these you know, things for ourselves in you know, in blueprints, we've got to think about what we can do with our array. Now, what I'm going to do with it is I'm going to encode with you our priority queue in C++. Okay, but I've just shown you that it's not impossible for you to do it strictly with blueprints. You don't have to use C++ at all, right? The challenge is how many lines of code in C++ might be only like, let's say, a few lines of code. Well, maybe let's say under 50 lines of code, but then the blueprint might look like massive, and it's going to have many, many functions and all that kind of stuff split up into a lot of stuff that you'd have to look at. So I feel like when I'm making a collection, I'd rather do it in C++ than doing it in blueprints, only because it's such a low level thing that I'd be creating, and I want to be able to use that thing and obfuscate or hide all the details about how that thing would work. All I care about is, can I add data to it? Can I get data from it? And does it do everything I need it to do? As opposed to, having to show all the details. It's almost like I want to create a little black box for my my users, you guys, right? I'm the developer. Let's suppose I'm the senior developer and I want my junior developers just to use my collection. I don't need to show you all the details on how it works. You just have to trust the fact that what I'm giving you is going to work exactly like I say, right? That's the way we would do it, and most likely I would do that in C++, not on the Blueprint side. Questions for queues, stacks, and everything we've covered for today? I want to talk about this because I don't want to make you crazy, but I'm spending quite a bit of time talking about data structures, which means that there's nothing that stops me from putting something like this on the final exam, right? Where I'm asking you to convert something that I'm giving you into from C++ into blueprints, right? So that's why I'm telling you this stuff, so you should know how to do it. Okay? Any questions? So, summary. We've covered 3 different types of structures today. We covered stacks, queues, and linked lists. And stacks, again, we talked about how they're related to the call stack. The closest relationship is the call stack, or a stack of cards. I want to make a card simulation. I'm going to use a stack, right? If I'm going to use a queue, that's kind of like a lineup. I can make a bullet pool out of that. I could make what we're going to do, which is organize a set of nodes into from lowest to highest. A priority queue is a really great way of doing that. That's something I can use. I can also use a list, right, for that as well. And a linked list, which is something we've done already. Think about, again, patrol points. I want to go from one patrol point to the other. I want to have a set of decisions that I want to do in order, right? Or I want to backtrack. I want to keep track of all my commands that I put in, every single command that I put into to my application. And then I want to backtrack to the previous command, right? Doubly linked list, right? Or I want to redo, I want to go forward, redo, or undo, right? Undo, redo, that's a linked list, or doubly linked list, right? And how many nodes I remember, I'm just adding more and more to that doubly linked list where I can traverse back and forth, right? So those are the things that I want you to think about. That's how we make our data structures. Data structures, my friends, are the foundations of programming. Without data structures, we cannot make more complex code. Well, we can, but then you may not understand how it all links together, right? And that's why I'm telling you all this stuff. All right, that's it for me today, guys. I want to wish you a happy weekend. It's going to be nicer temperatures, maybe not the nice weather. Tomorrow might be a little bit weird in terms of rain, but at least we're going to get rain. And I always say rain better than snow any day, right? So good luck, and we'll see you next week. Again, remember next week is remote. That's what the plan is. Not because I want to be remote, but that's the plan for this week, week 9. And then after that, week 10, I'm very confident we'll be in person together. Okay, by then I think things will be back to normal. Guys, thank you so much, and I'll see you guys next week online. Thank you. I'll stop recording now. You too.